Recording. Okay, so as I mentioned, I'm gonna speed through this last portion of it because it's not something we're gonna be practicing in class. I want you guys to be aware of it, but I want the bulk of our time to be practicing the actual lab and what that's gonna look like. Okay, so the same way we've been talking about confidence intervals as estimating a parameter for the population. Specifically, we're usually looking at the mean. You can do the same thing for proportions. So the standard error of a proportion, this would be the formula for it. Again, it's based on the central limit theorem. So the higher your sample or the larger it is, the more it'll mimic the population distribution. And it has the same assumptions that it's approximately a normal distribution. It has a mean and it's equal to the population proportion, all of that. Okay, so that's what it would look like. Specifically, if you then measure a sample, because that's looking for the population again, which we don't usually have those parameters, but for a sample, you can get the standard error of proportions. You can use, again, specifically within that sample where your SP is gonna be the estimated standard error of the proportion. P is the sample proportion, 1 minus P is the inverse, and N is your total sample size. So if I were to calculate the estimated standard error for that Gallup survey about environmentalist identification, which was 42% identified as environmentalists, this is in the first portion of our lecture today. Based on a random sample of 1,019 adults, that would be my N, the percentage of folks who identified as environmentalists was reported to be 42%. So that's the proportion, that's my P. And then I do 1 minus P, and it's again divided by my N, okay, which ends up being 0.015. I have to do the square root. That gives me 0.02. That is my standard error of the proportion. Okay, we're gonna deal with that. So few things we need to be mindful of. What is the sample size, right? What's my N looking like? And does it actually approach the population? And then what is the sample proportion of P and 1 minus P? When they're about 50%, a sample size of at least 50 is sufficient. But when they're not equal and they're really disparate, right, my proportion and 1 minus, then it needs to be bigger. Okay, so just what I said. When P is greater than 0.50, a larger sample is required to meet the assumption of normality or a normal distribution. Okay. We're doing something very similar as what we did earlier. So the way we calculate a confidence interval is we take our proportion, so it's proportion rather than mean, plus or minus your Z times your standard error of your proportion, okay? So as an example, first you would measure that proportion within your sample. You would calculate the estimated standard error of the proportion. You would then decide on a desired level of confidence, just like we did with the other one. Find the corresponding Z value, calculate the confidence interval, and then make sense of your data, interpret it, so to speak. So if I'm looking again at that 42% are environmentalists, and I want a 95% confidence interval, I need to have that 1.96 Z value times 0.02, which is the value we received earlier. Let's go back for a second so everyone's on the same page. This is it, standard error of the proportion. Okay, I do that multiplication and then I add it and take it away from, what was that? No, okay. I take it away from my proportion. So it ranges from 0.38 to 0.46. What does that mean? So if we take a large sample, 95% of those who contain the actual population mean would be within that range. So a large sample, I feel confident that that's the percentage or the proportion of that sample that would identify as environmentalist. Can you see, especially with politics, how important those values are and having a confidence interval? right? Because people are always polling before an election to try to get a sense, are people going this way or that way, to get an estimate on how people will do.
And so this is where it comes in politics, where it's like, oh, they're up 3 points. Oh, they're down 5 points. And like
Right.
1 point is significant because it's this.
Exactly.
Okay, yep.
Yep. Okay. So exactly the same. So we can look at 39% of Americans opposing laws that require so this is just an example for your book, transgender people to use the bathroom that corresponds to their gender at birth. We've got an N. We have our proportion, right? Proportion is 39 or 0.39. 1 minus 0.39 would be at the top, divided by your N, which is 1,049. Use a square root, you get a very small standard error of the proportion. If it's 95% and you would calculate it, you would insert that into your Z, 1.96, right? And you would then add it to 39%. And then you'd have a 95% confidence interval as to what's the proportion of people and how they felt on this given issue. Okay, are we understanding the crux of how this is done? Questions before we move on to the lab?
Okay, sorry. Can you just like do that one more time? Explain that
Yes.
one more time.
In fact, why don't we actually calculate that as a class? Because this is a good example to just do before we skip over to the next slide, to do as a group. Okay, so my advice, I'm kind of a visual person. You can see paper, pen, all in hand. I would recommend you do the same. So the first step is identifying where you plug in the information you were given in your prompt to fit into the formula, right? So I need to know, what is my proportion? I need to know what's my sample size. Okay, so what is my proportion for this example?
Is it? No, it's not the 95. What is it then?
No, 95 is the confidence level.
Yeah.
What is my proportion? Where do we see a number that looks like a proportion?
In the first little bullet point.
Right, in the first start. So when it says 39% of Americans, that's my proportion. Okay. So I would write 0.39, and I'm going to do a little times. In parentheses, I'm going to write 1 minus 0.39. Okay. You take the proportion and the inverse of the proportion. That mathematically, this is what we're doing when we're dealing with proportions. Okay. So let's figure out, what is that number? So I need to multiply 0.39 minus, or multiply it to 1 minus 0.39. What is 1 minus 0.39?
61. Point.
Yep.
Yeah.
0.61, you got it. So then I'm taking 0.61 times 0.39, which gives me what?
0.2379.
Right, so I'm gonna round that to 0.24, just to make life easy. Okay, then I need to divide that by N. What is my N?
The 1,049. Right.
1,049, right. So I'm taking 0.24 divided by 1,049. Itty bitty number, right? What do we get?
0.0002.
2, yeah. So I would say 0.00023. We'll just round to that.
Okay.
Is that my answer, or do I need to take it one step further?
No, then you have, yeah, you have to do the square root.
Square root, exactly. You do the square root of that. Oh, is this not gonna let me do square root?
Yeah, it's not. I have like my phone calculator right now.
Yeah, that's what I'm using too. And somehow, usually the calculator will just, if you turn it on its side, will let you. So let's do it here. Square root of 12323. Okay. Okay, the answer I got according to the interwebs is 0.061. Can somebody verify me that the internet's not lying to me? Or is everyone using the internet? Because no one has a calculator anymore, right?
The internet is useful.
Is that about right for what's that?
You said what'd you get again?
I got 0.061.
I think I put the wrong number in here. Yeah,
No, I might have done it wrong. Square root.
it was 0.0004023.
Mm-hmm.
Yep, I got 0.0047.
See, this
You
is what's
said-
problematic because I'm just plugging it in here and now I'm getting a new number. I'm getting 0.015.
Oh yeah.
I got
Okay.
0.015 when I did it.
Yep, I'm
Okay.
on the internet, so
We need one more person to verify that we're doing the right thing here.
It was 0.00023. Right?
Point zero-
3 zeros.
3 zeros, yep, 2, 3. So now I've looked at it on 3 sites and I'm getting 0.015 as the square
That's
root
what
of
I
that.
got too.
I
Okay.
did zeros, that's why.
Okay. We're going to say that's the standard error of the proportion based on that. You guys, this is bad. This is why, again, we use Excel and calculators. All right, so what's my next step? If I'm trying to find out the interval for my proportion, what do I need to do?
Then you
What's
do the 0.34. No, what was it? The 0.39 plus or minus. What were you gonna do? 95. So what was that? 168. No. What is that?
1.96, very close.
Yeah, 1.96, and then you do it over that whatever we just got the square root of.
You got it. That's exactly right. So what I'm going to do is I'm going to do 0.015 times 1.96. Okay, that'll give me 0.0294. I'm going to say 0.03. I'm going to round. And then I take my proportion, which is 0.39, and I do plus or minus this 0.03. Did everybody get that?
Could you say it one more time a little slower?
Yep. And now you can even see my little chicken scratch here. So you are going to then take your 1.96, which is my Z, right? And again, if I'm, I don't know if you guys can still see the screen here. This is Z, 1.96. And then I'm multiplying that by 0.015. That got me 0.03. So that's that half of the equation. And then I need to do plus or minus my proportion, which is 0.39. So if I take away what's that?
Your screen keeps on jumping away, and I'm like having to scroll through and find it.
Does that help?
Yeah, there we go. Yeah, there we go. Sorry.
Okay.
Like it keeps on picking up I think Kyle's mic maybe, and it keeps switching between you guys.
Oh, sure. No, that's fine. Okay, so this is where it's at. So I'm multiplying here my Z times my standard error of the proportion, and then I take my proportion and I do plus or minus that value, which gives me a range of I can't really see what I'm looking at here, 0.36 to 0.42. So if I'm using, again, back to the example, that would be 36 to 42% of Americans, I forgot the example, hold a view about laws requiring bathroom use. Why is your textbook weird? Like, can't we use something fun like percentage of people who want to own cows? Like something simpler. But anyway, does that make sense how we walk through that?
It looked
Yeah.
good to me. After I could actually see your formula, it made a lot more sense. And then everything kind of clicked.
Good.
So yes.
Okay. So if we go back to here, this is again the formula you would use. You need both because first you need to find the standard error of the proportion, and then you plug that value in to your confidence interval for the proportion. Confidence intervals are not rough. They seem tough because you have to use 2 different formulas, and for people who are like, math, hate it, you know, seems like a lot, but it's not complicated mathematics. I mean, you just verify yourself if you're doing it online. But we're going to be using Excel. Excel just gives it to us, so much better. Okay, so the last slide is just a review of key terms, so we're good on that. Okay, I want to now share, where is my Excel? Show all windows, let's see. You guys, it's embarrassing how many windows I have open.
Join the club.
Okay. Oh, it's really embarrassing. Okay, can you guys see Excel right here?
Yes.
Okay. Oh, let's fix this. Okay, so I created a random sample of grades for students in a given class on basic math abilities in the 3rd grade. Let's say this is like a standardized test by the state of Michigan. They want to know on average, what is the confidence interval of the score they get on their exit math class test at the end of a year. Making stuff up here. So what is the first thing I need to do if I'm going to calculate? So I'm going to write here at the top, 95% confidence interval. What's the first thing that I need?
Find the mean.
Yes, find the mean. How do I find the mean? So for today's class, we are going to utilize some of the shortcuts of Excel because it's delightful and it makes things easy for all of us. So what is my mean and N?
Mean is 78.733. So just 7.
Yeah. And what is my N?
31.
I think N should be 30, right?
30?
30. Yeah, I skipped a line at the top. Didn't mean to.
I
This
didn't
is
see that.
classic me. I always like to have a little extra space so I could write titles. Okay, so right here, I know that my mean equals 78.3, N equals 30. What's the other piece of information that I need?
So we're doing 95%. So would it be the 1.96?
So we're skipping ahead there to Z. What else do we need first?
The standard deviation, right?
You got it. So how do we get the standard deviation?
You have to do the x minus mean and then the x minus mean squared, right?
You got it. Now, let's have ourselves a little bit of an easier time. Oops, what's going on here? No. Don't know what happened. Here, I'm going to do standard deviation. What is this one? Okay. So I did equal at the bottom here, equal ST. And you see all of this popped up as options for formulas in Excel. This third one down, standard dev.s, is estimates standard deviation based on a sample. That would be pretty good, right? So I want us to try something. We're going to do that one. Oops, I did not like it. It said, what do you want me to do? Let's try that again. Okay. Okay, and then I'm going to take this value and bring it all the way up. I think I messed things up here. Okay, 12. I don't know what happened here. This should just be 80. Okay. 82, okay. All right. Now this is just me wanting to know how to, okay. So this is just if you have another one, sample, okay, for older version. Okay, so my standard deviation is 12.08. And you're probably like, I curse you, teacher. Why did you have me do all the columns? Because in doing, there is learning. But you can also just do it like this. Okay, moving right along. Let's not focus on that. So what's the next thing we need to do? So if we go back to our formula, what's the next step that I need to do in order to calculate a confidence interval? Some to do with standard deviation, maybe sample size. Is that ringing a bell?
Is it the standard deviation over the sample size squared? No. The
Square rooted.
Yeah.
Yeah,
square
and
root.
what is it we're solving for with that?
That is the
That's
it's the sample error.
Yes, the
Yes.
sample standard error. Excellent. Okay, so standard error equals, right, 12.08 divided by, I'm going to write square root of n. What is n? It is 30. Okay, so I'm again gonna cheat. I'm gonna, well, not cheat, I'm gonna be clever. Let's not call it cheating, right? It's utilizing the tools at our disposal. Square root of 30 is this number. So now what I wanna do is, so standard error equals, no, that's not gonna like that. So let's just do equal 12.08 divided by 5.48. I'm just gonna round, and that is my standard error, okay? So standard error equals 2.20. Okay, now how do I calculate a confidence interval? I have to take my what?
Standard error and forgot. Hold on, let me look.
Let's write it all out. So we're gonna take first our mean, right? Plus or minus what?
The, what is it called again? The
Z?
Yep,
Oh, you're gonna say, so Z times the standard error.
error. Yeah.
Okay, so that's the formula I'm working with. I'm not using the fancy writing because we're on the computer, but that's the gist of it, okay? So what is my mean?
The 78.3.
78.3, right? Plus, so I'm gonna write them all, both out. So 78.3 minus, okay? So we'll just do them both that way.
And we're gonna do the 95, right?
95, yep.
Wait, is it? Oh,
It's 95% confidence level. Yeah, so what's my Z for 95% confidence?
1.96.
Yep, so 1.96 times the standard error, which is what?
2.20.
You got it. Okay, so this part looks very similar. I'm gonna copy it for ease of time. Okay, now we need to calculate it. So I wanna know, what is that value? What is 1.96 times 2.2? That's 4.3. So I'm doing now 78.3 plus 4.31, and I'm doing 78.3 minus 4.31. So my 95% confidence interval is 73.99 to 82.61.
Boom.
Boom. I know. Okay. Questions, comments, concerns. What do we think?
So that's
There's
all
so
we're
many
doing for the
steps.
lab.
What was that, Bree? I didn't hear you.
That's all we're doing for the lab.
Yes, not with that data. I have other data for you guys to use, but it's the same idea.
Okay.
Okay, what were you going to say, Kyle? Did you say something?
Oh, I
or-
said it's just so many steps. It's interesting, but long.
It's long, but think of all the steps you really cut out by not calculating standard
Oh.
deviation the long way, right?
Oh, knowing all the shortcuts through Excel, beautiful.
They're beautiful. Yeah, whenever you have questions, I'm sure, let's just go to the help button. How do I? Okay. Now, for the lab, you need to do all of this and show me how you did it. Don't just write random numbers. I want to know that, so kind of the way I talked it through here, right? Doesn't have to be identical, but you know what I mean? Like step by step, so I know what you're doing. Because the last thing I want is from someone to just write this, 73.99 to 82. I'm like, how'd you get to that, right? Show me your thinking, show me your process. If we were in a classroom, show me your work. That's kind of the point here. But the next step is I want to make sure that you can give some sort of interpretation. So again, my prompt was, this is the 3rd grade math final exit test. So if I'm asking for general students in the state of Michigan, how are they performing? What's their scores going to be? I could say I'm 95% confident that on average, students in the 3rd grade in Michigan are going to score 73.99 to 82% on that exam. Okay. So I want you guys to have a sentence like that at the end that describes your finding. Okay, does that make sense?
Yeah.
Okay, all right. Now let me see if I can find my other Excel sheet that has my data set. We could use this one. I don't think that's the one I had open, but this could work. Okay, we're gonna use this one, but I'm gonna edit it because I want you guys to compare between the number of TV hours watched for parents who are married and those who are not. I've got enough in my sample set, so I'm just gonna divide it. I'm gonna be nice. I'm gonna divide it first so you guys can calculate it for each.
Thank you.
No problem. Okay, so I'm gonna, because you guys could totally do this, you just have to sort and divide your data. I'll just make it a little easier and split it up. So I will do that for you guys. It is gonna be, okay, let me share my screen again so you guys know where to go. Here it is. Okay, do you guys see Course Connect?
Yep.
Okay, so right here, Lab 3 confidence interval is where you're gonna be submitting it. And I'm gonna change the data here for the confidence interval, but that's where you'll be able to find it. Sound good?
Perfect.
Okay. Please reach out if you have any questions, comments, concerns, something doesn't make sense, just let me know and I'll be happy to help you guys out.
Thanks.
All right, have a great rest of your day. We'll talk to you soon.
You too.
Bye-bye.